Now, solving linear inequalities is very similar to solving linear equalities, but there's a few slight differences. So when we're solving equalities, we know that there was an equal sign. Now you notice that we will have greater than or less than symbols used. So most of the rules are the same, but there's just a couple instances where we need to be careful when we're working with linear inequalities. So if I have 4x plus 7 is greater than 3, I'm trying to solve for all my values of x which satisfy this. So as we did with when we're solving linear equations, we subtract 7 from both sides. So 4x would be greater than negative 4. And then if I want to get x all by itself, I need to divide both sides by 4. Therefore x will be greater than negative 1. So that's no different to what we've done with linear equalities, but this is representing more than one value, so x can take all values greater than negative 1, and that satisfies this inequality. So what if I had x minus 1 over 3 is less than or equal to minus 5? Again, when we're working with something like this, we are going to try and get rid of this 3, so we multiply both sides by 3. So on the left, I'm going to be left with x minus 1. This symbol is going to stay as is less than or equal to if I multiply this by 3, we have minus 15. Then if I want to solve for x, all the values of x that satisfy this, I have to add 1 to both sides. So x will be less than or equal to minus 14. Again, x is taking more than one value. It's all values of x that are less than or equal to minus 14. When working with linear inequalities, there's some rules that we need to be aware of in addition to what we have already learned to do with when we're solving linear equalities. So consider the following. Here I've got a statement that 6 is greater than 2. Okay, so 6 is greater than 2. If I was to, say, add 3 to both sides of this inequality, because I can't just add something to one side, but if I was to add something to both sides, so if I added 3 to this side of the equation and I added 3 to this side of the equation, we would see that on the left I would have 5, on the right I would have 9. And we can all agree that 9 is still greater than 5. So that equality sign would not change. What if we subtracted 3 from both sides? So looking back at our initial statement, 2 is less than 6. If I subtract 3 from the left, I would have negative 1. And if I subtract 3 from the right, I would have 3. 3 is greater than negative 1. So again, that checks out, and the inequality sign would stay as is. What if we were to divide both sides by 2? So if I was to divide this side by 2, I'd get 1. If I was to divide that side by 2, I'd get 3. So 3 is greater than 1. Again, that makes sense. Now, let's consider something a little different. What if I was to divide both sides by negative 2 rather than positive 2? So if I divide 2 by negative 2, I'm going to get negative 1. And if I divide 6 by negative 2, I'm going to get negative 3. Now this is interesting because negative 1 is greater than negative 3. So you can see that when we've done this division by a negative value, that the inequality sign actually changes. And when we're solving linear equalities, whenever we multiply or divide by a negative value, that occurs. The inequality sign changes. So whenever we multiply or divide by a negative number, our inequality sign changes. So whenever we multiply or divide by a negative number, our inequality sign changes. So let's see this in practice. So here I have an inequality, so let's get x by itself. So I start by adding 3 to both sides. So minus 5x will be less than 10. Now, to get x all by itself, I need to divide both sides by negative 5. So x, and then on this side, if I divide 10 by negative 5, I'm going to get negative 2. But remember, I've just divided by a negative number, therefore our inequality sign changes, so it now needs to go this way. So this is representing all the values of x greater than negative 2. If you want to draw that on the number line, here we have x, 0, negative 1, negative values of x greater than negative 2. So we have an open dot and all the values greater than negative 2. Okay, what about b? So if I have 1 minus x over 8 is greater than or equal to negative 2. So we'll start by subtracting 1 from each side of the inequality. So if I subtract 1, I'm just going to be left with minus x over 8. And if I subtract 1 from this side, it's going to be minus 3. Remember, when I'm adding and subtracting values, it doesn't change my inequality sign at all. Now, to get this x by itself, if I multiply both this side by minus 8 and this side by minus 8, it will make this positive x, so I'll be left with x. And if I multiply this by minus 8, it's going to become positive 24. But remember, I've just multiplied both sides by a negative number, therefore my inequality sign must change. So x is represented by all values less than or equal